So hello everybody, this is Sivam back again with a new video on a video series of CSIR-NET JRF for Sciences. So in this video, I am going to explain about temperature distribution of Earth. Now this topic is very important as far as our exam is concerned. In the paper, we have lots of questions in B section as well as in C section from this particular topic. So in B section, you may have around 2 to 3 questions directly related to this, while in a case of C section we have sometimes 2 questions, that means around 8 marks is from this chapter, and here we have 6 marks. So you can say total it is 14 to 15 mark, you can say close to that. Here we have from this very chapter. Now let's start this chapter with the basics and see our CSIR exam or this earth science is basically based on basics as well as conceptual numericals. Okay, so you have, if basics know, then everything is all right. So without wasting time, let's start. Here we have first slide. Okay, so here we can see that transfer of heat. There are different ways to transfer heat. Now before starting this phase of transfer heat, let's start with a topic, heat, and how it is different from temperature. So temperature is basically a degree of hotness or a coldness of the body, and heat is basically, you can say, it's a form of energy which always moves from higher temperature to the lower temperature region. Okay, so it's a energy. Okay, heat is like, it never means ki, this particular body is more warm and more cold. That is temperature. If we consider the hotness and coldness, then we consider about temperature. Temperature is nothing but you can say it's a average kinetic energy of the particular object. If the kinetic energy is more, that means it has more temperature. If its kinetic energy is less, then it means it has less temperature. Okay, so let's start with the first term, that is conduction. Now what is conduction? Conduction is basically a flow of heat in which there is movement of energy, okay, without movement of material. Now let's take an example. Suppose we have a bunch of cycles. Okay, we have bunch of cycles like this. Here we have one cycle, another cycle is over here, another cycle is over here. All cycles are in stand. Okay, now suppose if you push with some force over here, all cycle will simply fall down. Means you are pushing, you are giving energy to this cycle, and due to energy of this cycle, it gives to this one, like this. It's a continuous chain of reaction, right? Chain of reaction goes on from this side to that side. So here what happens? Energy is moving, right? Particle is not moving. Cycle itself doesn't moving. Cycle is not moving, right? Energy is moving, and that is called conduction. So whenever we touch any metal object, okay, and suppose one arm of that metal object, one point of that metal object is in fire, we feel heat. How? Here each atom transfers some amount of heat from atom to atom. Okay, in this way there is a movement of heat, but there is no movement of atom. That is called conduction. Now convection. So here we can see conduction is here, right? This whole thing is made of a metallic body. So we feel some heat. This is conduction. Convection is movement of heat as well as movement of particle. Okay. So here we can see that this base is close to the heat source. Heat source means here we have high temperature, right? Here we have high temperature. While at this point, this is in blue color. That means here it is in contact with the atmosphere, and we know the temperature should be less compared to this. Here we have more temperature, here we have less temperature. And we also know that if temperature is more, that means density is less. So here we have less density. While at lower temperature, density is high. So here we have high density. Now since it is low dense, it is less denser, so it will simply move up, and this one is highly density, this one has high density, so it will move down. So in this way there is a formation of cell inside a this span, and this is called convection. So in convection we have movement of energy, so that hot water is moving up and cold water is moving down. So this is a movement of energy as well as movement of material. So water itself is moving, right? So this is called convection. Same thing is happening in our mental convection cells of mental, right? Okay, now here we can see this convection, and finally we have radiation. Now what is radiation? Okay, so radiation is basically a kind of electromagnetic wave, you can say. It's a kind of electromagnetic wave which requires nothing at all. No material medium is required for the movement of radiation. Basically it is an electromagnetic wave, and it moves in the direction of propagation, and here the vibration is always perpendicular to the direction of propagation. Okay, so like sunlight covers 150 million kilometer, okay, out of which maximum area is space, right? It is complete blank. So in this space there is nothing, right? There is no material medium, still wave is moving. How is it possible? So it's all because of radiation. See, it is radiation, it's an electromagnetic wave. It doesn't require any material medium, while like longitudinal wave right now I'm talking. Okay, so here I am producing some kind of longitudinal waves. This requires material medium for its propagation. Is this clear to you? Now if we compare this whole thing with Earth, conduction is there in our lithosphere. Okay, convection is there in our mantle. It is there in outer core, and mantle has convection thing. Lithosphere has conduction. Radiation is there on the Earth's atmosphere. So sunlight is coming from the space to the Earth's surface. So this is an example of radiation. And here also we have some example of radiation. So whenever we put fire, we feel heat, right? Without touching it. How we feel? It's all because of radiation. So now moving to the next slide. Now please give me the answer. Here we have a question: heat is transported in a lithosphere through. So this is CSIR question, previous year. No, it's an official question from CSIR. It is an official model paper, and it's a simple question, right? I told you just now, heat is transported in the lithosphere through conduction. Convection is there in where it is there. Advection is where, convection is where. Both are in mantle. Now what is the difference between convection and advection? The vertical movement is called convection. So we have suppose mantle plume which produce hot spot activity, right? So it is example of convection, while advection is the movement of this mantle plume, or you can say this convection cell. When it comes to the surface, it simply drags plates, right? So here we have two plates. Now two plates are moving apart by these convection cells. So these are example of advection. Now what is radiation? Radiation is simply sunlight. Okay, it's example of radiation. Okay, now another question from CSIR. In the atmosphere, heat is mainly transported by heat is transported by, again, convection. So here we have cells, right? Convection cells. Here that is not related to this subject, so let this, we'll discuss this later. Now let's see factors affecting temperature distribution. The first thing is angle of incidence or inclination of sun rays. This is the first factor. Now these all points are very important. Okay, so be focused on it, and let's see. So suppose this is the Earth. Here we have, say, sun. This is sun. Okay, now see, the distance between this point, this equatorial region, from sun is 150 million kilometer. Okay, while this point is a hypotenuse, right? Here it is at hypotenuse. So this point should be longer distance. Okay, these polar regions are at long distance from the sun. Long distance means now light travels greater distance to reach this polar surface. And we know if you increase the distance from the source, the intensity of light will decrease, right? The luminosity of the light will decrease. The light get simply attenuated. It get either absorbed, refracted, scattered, possible. So there are n numbers of possibilities which can attenuate the light. That means if you decrease the angle of inclination, the intensity of light will decrease, and in this way temperature will decrease. That's why on the polar regions we have cold conditions, because here angle of incidence is very less, while on the equator it is 90 degrees. Is this clear? I hope it is clear. Now duration of sunshine. Okay, now on Earth's surface, the main source of heat is sunlight. Okay, if the duration of sunshine is more, that means technically we have more temperature, right? We have hotter conditions. Simply during summer days, the daytime length will be more than the night time. So duration of sunshine is more, that's why heating is more. And yeah, it is as simple as ABCD. Okay, third one, transparency of atmosphere. Now this is also very important. Okay, suppose here, just erase it. Now sunlight is coming all the way towards the equator. Now suppose here we have clouds. What happened? It simply reflect back the sunlight back to space. Or suppose there are some particles in the atmosphere. So these lights get scattered into multiple small beams after interaction, possible. Or suppose any particle is there which is made up of, say, carbon, black carbon, which is formed by burning of fossil fuels. Suppose this is a black carbon aerosol. Then what happens? It simply absorbs the sunlight. So all three things are possible. Either it get reflected, it get scattered, or absorbed. And in this way, the intensity of sunlight which is reaching to the Earth's surface will decrease. Right? So if intensity will decrease, that means temperature will decrease. Okay, so these three factors, scattering, reflection, and absorption, attenuate the light. And in this way, it will decrease the surface temperature. Now let's talk about albedo. The fourth point, what is albedo means? Albedo is simply the amount of sunlight which is, suppose this is the object. Suppose n amount of sunlight is incident on this surface, and then n minus 1 is moving back to the space. So this is coming from the sun and this is moving back to the space. N is coming, n minus 1 is going. So the ratio of this is called albedo. How much is coming to the surface and how much is going back. This is albedo. Okay. Now, if a surface is reflective, if a surface is smooth and suppose it is white in color, then it has ability of more albedo. It can reflect more and more light. Sometimes albedo is also a function of geochemistry. Okay, so different rocks has different amount of albedo. They reflect light differently. Their optical properties is not same. Okay, let's take an example. Okay, so the polar ice will reflect 95% of solar rays, while the world ocean, that is in liquid state, only reflects 5 to 10%. Okay, that means if reflection is 5 to 10%, yani 90% is either getting absorbed or getting scattered. Okay, so this is the concept of albedo. Now land sea differentiation. Okay, so suppose this is India, here we have Sri Lanka. So this is land, this is sea, and here we have unequal distribution in the entire globe. Suppose this is the globe, we have unequal distribution of land and sea, right? Now we know that at every latitude the intensity of sunlight is same, but absorption of sunlight is different. How it is different? The thing is, different latitude we have different things, right? Suppose this is 15-degree latitude. Now on 50-degree latitude, somewhere we have basaltic region, somewhere we have deserts, somewhere we have, say, oceans, somewhere freshwater reservoirs. So everything is different. Their optical property is different. Why? Because their geochemistry is different. So they interact with light differently. And in this way, the heating of same latitude will be different. Okay, it depends upon geochemistry of that particular area. So I hope this is clear. Now, sixth, that is prevailing wind. Now, how wind affects temperature? Let's see this. Okay, now suppose wind is coming from the polar region. That means these air masses should have dry and cold conditions associated with it, right? If any air is coming from the equatorial region, now we know that equatorial region are energy sufficient regions, their temperature is more. That means that wind is, it can be warm, no doubt. Suppose it is coming from equator, that means it is warm. If it is coming from equatorial ocean, then it is warm as well as moist. So here we can see that this prevailing wind has different temperature associated with it, and these are called air masses. Okay, I'm talking about air mass. I will discuss it in later. What is air mass? This is whole 2 hours thing. Okay, air mass, it's not a easy thing. I'll discuss it later. Till now, just remember, if wind is coming from any particular area which has certain characteristics like warm, that region is warm, that region is dry, like deserts. Deserts are dry, there is no water at all. And at the same time, if the desert is close to the equator, that means it is warm. So the wind which is coming from that desert is warm and dry. So prevailing wind shows some temperature, and they also affect temperature of entire world. अब कैसे? Let's see. Now let's assume this is our Earth. Wind is coming from this side, polar side, and one wind is coming from going from this side, equatorial side. So what it do is, it took some heat from equatorial region and spreads all the heat in this latitude, and it took from some coldness from the polar region and spreads the whole coldness on this region. So in this way, they also affect local climate by increasing and decreasing the temperature. Now, aspect of slope. Okay, aspect of slope. So for that, I have a figure, a very good figure. Let's see this. Okay, so let's erase it. So this is our Earth. Okay, this is equator, 0 degree. This is 30 degree north, 30 degree, south, and 30 degree north. Now somewhere here we have 23 degree and a half and 23 degree and a half, north and south. Now we know that our Earth is tilted by 23 and a half. That means sun can move in both the hemisphere till 23 and a half degree latitude. It means, see, our orbit is like this. This is sun, Earth is like this. It is tilted. Okay. So during the month of June, the sun is at 23 and a half north, because Earth is tilted 23 and a half. Agar Earth, suppose due to law of axial tilt, law of obliquity. It is a part of Milankovitch cycle. Okay. Now anyhow, suppose this tilt changes to 24.5. Then after certain years, sun will move till 24 and 5. Okay. What I'm saying is, in June, sunlight incident at 23 and half at 90 degree. Okay. While in December, sunlight directly incident on Tropic of Capricorn, that is 23 and half south at 90 degree. And in autumn, spring and autumn season, we have 90-degree sunlights at equatorial regions. Okay. Okay, is this clear? Now, India is like this. So just now I said that sun can move till 23 and half. So till here, the angle of incidence is 90 degree. Beyond this, it never forms 90-degree angle of incidence. Okay, this is the maximum limit up to which angle of incidence is 90 degree. Now, this is India. Here we have Himalayas. Okay, beyond 23 and half. Okay, so I told you, suppose this is 23 and half north, and this is Himalayas. Sun never comes over here. Never, it's not possible. Okay, that means if sun is over here, the light on this face of Himalaya, so this is the southern face of Himalaya and this is the northern face. Okay, now consider this with respect to India. So this is the southern face of Himalayas, and the opposite face towards the Tibet, towards the China, is the northern face. That means this southern face is in direct contact with the sunlight, while there is no such light over here. Okay, mountain is like this, sun is over here, so it will simply lightens this part of the mountain, while this part is under you can say less light area, partially light area. Okay, now since this phase is towards the light, that means here we have human settlement. We need some kind of light for human settlement. Here there is a good crops formation is good, little moisture in the soil, due to intense heat, abundant sunlight is over here. While on this side, on the northern side, we have no sunlight, no crops, no human settlement, and this area is forested. So because this is less, here the light is very less. So this is the aspect of slope. I hope this is clear to you. Just use common sense. Okay, this is very easy. Now, okay. So this is also completed, aspect of slope. Now ocean currents. So let's see ocean currents. Okay. Now the thing is, suppose this is India. Okay. During summer, monsoon means from May till September, we have cold water currents along the western coast, and along the eastern coast we have warm water current. So here cold, here warm. Okay, this is between March to September. During winter monsoon, in the months of December, January, February, the movement of current is opposite. Now it will move like this. It will move like this. So here now we have a warm current and here we have cold current. Now how to know the given current is warm or cold? So it is very easy. Just see the direction of movement. Here the direction of movement is from higher latitude towards the equatorial region. This is equator, suppose. This is 0 degree, and here we have higher latitude. So since this is coming from the higher latitude, means more heating is there. So more heated water is coming towards the lower latitude. So that's why this is the warm current. Now here, this is cold current, cold current, C is there, right? And here we have warm regions on the close to the equator. So from equator towards this higher latitude, water is moving. Equator is already warm, so warm current is moving. Simply over here from high latitude to low latitude, so it is cold, and from low to high, that means here warm water, so warm water is moving up, that means warm current is there. Now how it affects temperature? It's a very common question. The thing is, okay, if you see most of the deserts across the globe, all deserts lie close to the cold currents. Why? Thing is why? Okay, let's take an example. So this is South America. South America. Here we have Peru-Chile current, which is coming from high latitude towards the low latitude. This is equator. This is high latitude. This is South America. Okay. This is Peru-Chile current or Humboldt current. Now, since this is cold, that means it is dry too. Okay. It's cold as well as dry. Now, wind is moving from this side to this side, from ocean towards the land. Suppose all the rainfall is from the ocean side, right? All the moisture rich clouds are coming from the ocean side. So what we do is, since it is coming from this way towards the continent, so think here we have what we have something which is cold in nature, which is dry in nature, and right now it is interacting with the incoming moisture. So what will happen? The thing is, here it interacts with this cold and dry thing, and it get converted into dry air mass. Since the water moving below is dry, so it also affect the air mass above it, and the air mass become dry. And when it reaches to the continent, since there is no such water over there, that means there is no formation of clouds. Cloud needs water vapor, right? Now this air mass is dry in nature. So there is no cloud at all. No cloud means desertification. No rainfall, desertification. That's why most of the desert lie close to the ocean currents. Now altitude. How altitude affect temperature? We know that as we move up in the atmosphere, temperature will decrease. And this is called environmental lapse rate. Okay. Now why there is decrease in temperature in troposphere? The thing is, in troposphere, the gases like H2O, like CO2, methane, okay, these gases are heat trapping gases. We know that our Earth release long wave outgoing radiation in IR field, in infrared field. Now these IR radiations are very conducive for absorption. They absorbed by this water vapor, CO2 and methane. And since concentration of these gases are more close to the land, that means warming is more over here. As you move up in the atmosphere, the concentration of these gases will decrease. And if it will decrease, that means absorption is also decreasing, right? Less absorption means less heating. So that's why as we move up, temperature will decrease. Okay, in the vertical section, in troposphere only. Remember, in troposphere only. I will discuss this in atmosphere chapter, where I will tell you why there is again increase in stratosphere, while again decrease in mesosphere, then increase, then decrease. I will discuss it. Okay, this is something else. So altitude is also completed. Now Earth distance from the sun. So according to Kepler's law, we know that our Earth revolves around the sun in an elliptical orbit, and that elliptical orbit has two foci. In that two foci, sun is always at one of the two regions. Okay, so let's take a image. So this is two focus. Okay, F1 and F2. Suppose sun is over here and Earth is over here. Earth is over here, Earth is over here. Okay, now you can simply see that the distance between sun and the Earth will change with the months. It is never the same. in 3rd of January and around 3rd of July or 4th of July. So suppose this is the 4th July position, 4th July, and this is the 3rd January. Okay, so on 3rd January, Sun is close to the Earth. Then you will say that, sir, why during January the thing is क्या कहते हैं, why we have winters? So in January in the southern pole we have summers. Okay, and in the same time in northern pole we have winter. So everything is opposite. I want to simply say that if you are close to a body, that means intensity of sunlight is more. If intensity of sunlight is more, that means heating is more. And if you are away from the sun, then no doubt the heating will be less. Okay, now seasons are not due to this thing, not due to distance. On Earth, seasons are basically due to tilt of the Earth. Okay, I'll discuss it later. It is not part of temperature distribution. But remember one thing, on Earth, seasons are basically due to tilt and revolution. Okay, while day and night is due to rotation of Earth. So this is completed. Latitudinal heat balance. Now, suppose this is Earth, Sun is over here. I told you, close to the equator, everything is warm because distance between Sun and Earth is less, while at pole, the distance is more. Okay, one more thing, here we have ice. Ice has more albedo. More albedo means more reflection. Okay, so absorption of light is less on the polar regions, while absorption of light on the equatorial region is more. In this way, latitudinal heat balance takes place. Okay, so remember, this equatorial region is heat sufficient region, while polar regions are heat deficient regions. Is this clear to you? Now finally, magnetic field. How magnetic field affects the temperature? Let's see. So here we can see that this is the Sun, here we have Earth, and along the Earth we have magnetosphere. This is magnetosphere. Now how magnetic field generated? First, let's see. So in outer core we have liquid iron and nickel. Okay, we know that Earth is rotating, right? If Earth is rotating, that means the liquid inside the Earth is also rotating constantly. And whenever these ions rotate in a closed path, they produce electric and magnetic field around it. And this magnetic field is nothing but a magnetosphere. So it protects us from this solar radiation, solar supercharged particles. Once it reaches the Earth's surface, suppose anyhow magnetic field is not present, then what will happen? So these particles are so charged that they can evaporate the entire atmosphere as well as oceans. So this magnetic field is very important for us. See, the same thing is not there on the Mars. On Mars, magnetic field is very weak, and that's why over there atmosphere is very thin, and atmosphere is important. If there is no atmosphere, that means temperature will decrease by 10 to 20 degrees Celsius, minus. Okay, on Mars the average temperature is minus 55 degrees Celsius. Why? Because atmosphere is thin. Now how atmosphere increase the temperature? So atmosphere has some greenhouse gases, and these greenhouse gases are very important to hold the temperature. If there is no atmosphere, that means the daytime temperature will be very high and nighttime temperature will be very low. For example, on moon, there is no atmosphere, so during daytime the entire moon is affected by this solar radiation, and during nighttime there is no such radiation, so everything whatever is absorbed during the daytime, it gets simply removed away, okay, or re-emitted away into the space. Okay, in this way nighttime is very cool. So yeah, these are the factors which affect temperature distribution. So I hope this is clear to you. And see, this is just a trailer. Okay, the entire atmospheric part is covered by me in 30 lectures. 30 lectures. Each lecture is 3 hours long. Okay, so that means 90 hours of lectures. Okay, and that is quite enough to crack CSIR. Okay, so yeah, with this, I'm leaving this session. So hope you like this video. Please come and join our institute, that is Career Avenues. Thank you very much, everybody.